Welcome, everybody. Today we'll be talking about cloud-native data warehouses and specifically introducing you to running ClickHouse on Kubernetes. My name is Robert Hodges, and I'll be your presenter today in this webinar. Before we dive too deeply into the content, I'd like to just let you know about a few things that will help you enjoy this more. First of all, this webinar, as you probably just heard, is being recorded. So we'll publish links to everybody who's signed up, so you don't have to scribble notes frantically. We'll get you the recording link as well as a link to the slides that you can keep for your records. Second thing, if you have questions, feel free to put them into the question and answer box. I can answer them in passing during the talk or at the end, as the case may be, or you can throw them in chat. It's not super busy today, so either way works. And just any question is fair game about Kubernetes, about ClickHouse, whatever. With that, let's dive in. So let me just check that we've got, looks like audio is working. If somebody can just confirm in chat that you can hear audio correctly and see the slides, that would be very helpful. And meanwhile, I'm going to go ahead and dive in. All right, so just a little bit about my background. My name is Robert Hodges. I'm the CEO of Altinity. So I run the business, but more importantly, I've been working on database services since 1983. So I started with something called M204, and I've worked with about 20 different databases, and of which ClickHouse is the last one. I've also done work on, was at VMware for a few years and worked there on virtualization and security. And it was at VMware, actually, that I was first introduced to Kubernetes back in 2018. I've been using it ever since. We've made a pretty major investment in it at Altinity, as you'll see. A little bit about Altinity itself. We're an enterprise provider for ClickHouse. So our goal is that if you are building analytic applications on ClickHouse, we're here to help. We do everything that's necessary to get your apps up and running, all the way from doing training and initial design help to 24/7 support to operating it in the cloud. What's most relevant to this talk is that we're the implementers of the ClickHouse Kubernetes operator and have a lot of expertise running Kubernetes. In fact, our whole cloud service runs on it. So we're quite familiar with it and big fans. With that, let's just dive into this. So this is an intro talk, and what we're doing here is we assume that you've heard of Kubernetes but don't necessarily know that much about it, and that you've also you're perhaps familiar with ClickHouse and you'd like to try running it on Kubernetes. So the idea with this talk is to give you all the information that you need to do that and kind of jump in and begin trying it out. So so with that, let's just talk for a little bit about what exactly Kubernetes is. So if you read the sort of sort of articles on the web, there's just a lot of hype around Kubernetes, and sometimes I've even heard people call it the new Linux. That's not very helpful, actually. What Kubernetes actually is it's an open source platform that does a number of things, depending on what you're interested in. First and foremost, it's what we call an orchestrator for container-based apps. So a container is something like Docker, although there are other kinds. It's a way of packaging software, specifically processes, and running a bunch of them together. And Kubernetes is designed to take these applications that consist of containers, deploy them, and manage them. The second thing that Kubernetes is, and this is from another angle, is it's defined through what we call infrastructure as code. So that when you want to define one of these applications, you give a specification that says what you'd like to see, and then Kubernetes makes it so. And we'll see examples of that as we go along. Third thing, Kubernetes is a great cluster manager. So you can take a bunch of storage and compute and network resources, glom them together in a Kubernetes cluster, and then start piling applications on, and Kubernetes will take care of ensuring that the application resources are deployed in some rational way across all your underlying infrastructure. And finally, you can see Kubernetes as an endpoint for automation, specifically for CI/CD pipelines, that the deployment process can be automated to the max, so that if you have CI/CD running in, sort of off your GitHub repo or your GitLab repos, you can actually have pipelines which just push stuff all the way into Kubernetes and get the applications deployed to your users. So it's a lot of things simultaneously. What I'd like to do now is just talk a little bit about what it actually does when it's managing applications. So when you use Kubernetes, it's going to present to you this appearance of a big cluster that's divided into these things called namespaces. So for example, every Kubernetes cluster has a namespace called kubesystem, and kubesystem is the namespace where all the resources that run Kubernetes itself actually run. There's another namespace that comes up by default. It's called default, and that's where, if you don't ask for a particular namespace, that's where your resources are going to be allocated. And then finally, you can make namespaces of your own. The namespaces are really just a way of partitioning the different applications and having them run in different areas so that they don't interfere with each other and you can keep track of them. They also have there is some ability to limit the connectivity between namespaces, have different security in different namespaces, so on and so forth. So it's kind of like, it's actually not all that different from the notion of databases that we have within a SQL server. Now, what happens is Kubernetes takes these resources in the namespace and it's going to map them to the physical infrastructure, which, as we see here, is one or more servers connected by networking, that's the green arrows, and with storage accessible. These are the three key things that Kubernetes is going to build on. So what's going to happen is that we need to have a way of defining a distributed application using Kubernetes. And so let's take a typical example of a simple application. This actually turns out to be Zookeeper, but it could be any of a number of distributed applications that actually have storage attached to each of the processes. And so what you'll typically find in Zookeeper is it likes to run 3 nodes. So you have 3 processes that each have their own storage. It turns out they're talking to each other and replicating. And then they have a load balancer in front of them, so that people, when they want to find Zookeeper, they just come to the IP address of the load balancer, the traffic gets routed to one of those processes, and then they get their request served. So that is the distributed application. What we need to do in Kubernetes is define resources that will allow Kubernetes to understand what it needs to do to make that application be a reality. So what happens is, if we have that application, and then we go and look at what we're going to find in resources, we're going to see these things called services, stateful sets, pods, persistent volume claims, and persistent volumes. Let's just walk through what each of these are. So, excuse me, I need to take a drink of water here. Sorry about that. So at the top, we have this thing called a stateful set. This is a construct in Kubernetes that's used to manage applications that consist of one or more processes with attached storage. What it does is it takes care of making sure that those processes, or these containers, have a rational name to them that's predictable. It also ensures that when these pods come up, they get correctly attached to storage, and if the pod gets restarted, it finds the storage it was using previously and connects to it again. So this is the kind of the overall manager for things. The pods themselves are just containers. So typically, and in the example I'm using today, they're Docker containers, but they could be other types of containers. There's a number of other types of containers that you can use. Docker, at least for us, is by far the most common. Then there are these things called persistent volume claims. And a persistent volume claim is a request to have a certain amount of storage, like, hey, give me 25 gigs of storage on Amazon EBS. And then that maps to an actual allocation of storage, which we call persistent volume. So by creating the persistent volume claim, Kubernetes will then there's a controller that sees this and is going to go ahead and actually tell EBS to allocate the storage. And then finally, the service defines a load balancer, which you can connect to, and then it will route traffic into one of the pods. There's also many other types of resources. I'll just give one example here. Config maps are a way of passing configuration data into into Kubernetes and into the applications, so that they can find out things like, hey, what's my name? What are parameters necessary for the process to start correctly? All that kind of stuff. There are many other resources besides that, but we won't really talk about them too much in this talk today. So the question is, how does Kubernetes get from some list of resources that defines a useful application to actually having them out in Kubernetes running as something that you can connect to and use? So the way that you do it is you put the specification for the Kubernetes resources in a YAML file. And here, just as a simple example, I call it sumfile.yaml, and this is a specification. So when we talk about infrastructure as code, this is a piece of YAML code that defines what you would like to see inside Kubernetes. And then what you're going to do is you're going to run a program called kubectl or kubectl. I'll probably call it kubectl for the rest of this talk. And this is a standard command line client that just takes that file and just sends it to Kubernetes. Within Kubernetes itself, there's a series of controllers which are basically watching for different types of resource requests. And what Kubernetes will do is it'll process this file and it will send the resource requests that are in the file out to appropriate controllers. And what they're going to do, each of those is for the resource that it's managing, it's going to go out into Kubernetes itself and do what I call adjusting reality. It's going to say, hey, if they're asking for something I don't see it existing, I'm going to make it. If they are asking for something and what I see is a little bit different than what they're asking for, I'm going to change it so that Kubernetes matches the reality. And that's basically how the application is created. The specification file is just tells what you want, and then Kubernetes makes it so. So rather than going more deeply into these pictures, it's just simpler to stop and show how this actually works. So let's go ahead and do that. I'm going to just 1 second. I'm going to pause my share to move something around. Give me a second here. Have to adjust the screen here a little bit. All right, let's go ahead and reshare. All right, so what I'm going to do is just show you an example of one of these specifications. So I'm going to show you a specification for creating a Zookeeper application. This just has one node. I want to keep it a little bit simpler than that picture I showed you. So let's go in and look at it. So what you basically see in the specification is requests that define a bunch of different kinds of resources. So for example, a service resource, as I mentioned, is a load balancer. This is defining a load balancer that clients can use to connect into an arbitrary Zookeeper instance. There's another thing called a headless service. This defines a resource that can be used to address individual Zookeeper instances. And then there's a very important resource, which is the stateful set. And that's really saying, hey, defining this application that has a state attached to it. And this becomes quite complex. So it is going to do things like tell how we want this updated. It's going to tell us, details that are helpful for things like Prometheus for monitoring, how to distribute the pods so that they don't all go down if a machine goes down, so on and so forth, to the containers, and in fact it goes on for quite some distance, even including the command in this case to start Zookeeper. So this is a fairly complex specification that somebody has taken a bunch of care to develop. We can go ahead and run that quite simply. Let's actually, I need to clean something up here. Just one second. I'm going to, before I run this, I want to make sure that things are fully cleaned. Let's see, delete. I'll do this separately. Give me 1 second here to adjust the demo so that it's kubectl. And this actually shows you how you get rid of resources. If I have a particular type of resource, in fact, this turns out to be a ClickHouse cluster, I'm just going to go ahead and delete it. And I'm going to make sure that there's also that there's nothing going on inside inside the namespace where I'm going to load this zookeeper. So let's just check that again really quickly. All right, so looking at the namespace, this is another one. Looks like we didn't clean up fully before this was, before starting this. Let's fix that quickly. So we're going to delete the zookeeper namespace, and as these resources clear out, we will then be able to go and make something new. So this will take just a second. You can see up here, our cluster is gone. So the thing about Kubernetes is that, and this is actually sort of the dark side of Kubernetes, is it's really easy to delete stuff. So as you're working with Kubernetes, it's fairly important to keep track of what you're doing and make sure that you're putting in appropriate guardrails so you don't delete stuff by accident. There's also a number of tricks that you can use to protect things like storage. We'll talk about that as we go further in. So here we go. We're ready to go ahead and start that, to apply that that zookeeper definition. So let me go ahead and do that. I'm going to run a script that will do this because it will create the namespace and also run the file. So what we do is we go ahead and we're going to create the namespace. So this is where the application is going to live. And then we're going to say kubectl apply -f, and we're just going to, and that's going to say, hey, pump that, go ahead and send that cluster, that file up to Kubernetes and make it so. And so in fact, when this happens, we can then go ahead and just say kubectl get all -nzk, so tell which namespace we're going to. Just look at all the stuff running there, and there's zookeeper. It's up and running. It's as simple as that. So that's a basic demo of how you create things in cluster in Kubernetes. You just load this file, and then Kubernetes goes ahead and whatever's in that definition, it makes it happen inside the on the infrastructure that Kubernetes is running on. So if we come back, what we can see is if we go back and look at the entities that were defined in that file, we see that these entities with the dashed lines talk about the network resources. They're in green. The things related to the processes, those are in orange, and then storage, which is in blue. And what we end up allocated in Kubernetes, in this case Minikube, is we're going to get a load balancer, we're going to get a Docker container that's running, and it's going to be attached to some storage. So this all happened just by loading that file. It looks like a lot of resource, but in fact, these as the applications get larger, these resources are just all the little bits that you need to build distributed applications. So speaking of Minikube, it's worth just talking about ways to run Kubernetes and where you can run ClickHouse clusters. And the basic answer is pretty much everywhere. So in development environments, I typically run Minikube, but there are many other things that people use. Minikube is fairly straightforward to run on Linux in particular. So it's great for development and testing. If you want to run self-managed Minikube, Kubernetes, where, for example, it's either on your own hardware or you're running up in the cloud. Two popular ways of doing it are a tool called Kops and another one called Rancher. These allow you to set up they will take care of setting up Kubernetes and getting it ready for use. And then finally, it's for people running in the cloud in particular, it's very popular to have what's called managed Kubernetes, where you call a service like Amazon EKS that will, you can either go through the UI for Amazon, or you can use Terraform, and you can basically set up Amazon or Kubernetes clusters, which are then managed automatically by the EKS service. And every major cloud has one of these. So Google has GKE, Azure has AKS. There's also things like services on DigitalOcean. There's Tanzu for VMware, many other providers for this. So that's all we have to say about Kubernetes. It is, and in general, what we want to do now is shift to discussing how to run ClickHouse on Kubernetes. So just in case you need it, here's a quick introduction to ClickHouse. So ClickHouse is a data warehouse. In fact, it's a SQL data warehouse. So it understands SQL. In many ways, when you first start it up, it looks a bit like running MySQL. There's some superficial similarities between the two SQL dialects. Like MySQL, it's very portable. It runs pretty much everywhere. Interestingly enough, it can actually run on anything. It can run on an Android phone. It can run as a container. It can run on a VM. It can run in rack gear. Doesn't really matter. The only key thing that you want to have is you should have Linux if you're running it production. So another thing that's another way that ClickHouse is similar to MySQL is that it's open source. In this case, it's Apache 2.0, so it means that you can take it and use it pretty much anywhere you want. You can bundle it in software that you're shipping, so it can be used for any business purpose that that interests you. Now, where it departs from MySQL is the actual data warehouse feature. So, for example, we store data in columns and with very high rates of compression. So this is similar to products like Snowflake or Redshift or Vertica. We also have very good parallelization of execution, so we can spread queries across multiple nodes. Moreover, within single nodes, the queries are vectorized, which means they're broken up into pieces, farmed out to individual CPUs, and we use what are called SIMD instructions, or SIMD, single instruction multiple data, which allow us to do things like calculating aggregates, say 4 or 8 at a time using specialized registers. ClickHouse also has built-in sharding and replication. So you can create shards, you can have replicas. We'll show you how to do this, and it scales extraordinarily well. If you build your application, if you use ClickHouse effectively, you can basically get linear scaling as you add resources, and this will work out to tens of petabytes. So it's a very powerful data warehouse, probably the best SQL, open source SQL data warehouse that's ever been developed, and is very popular at this point. So there's just one problem though. What I just described is a complicated, in fact, a quite complicated distributed application, particularly because we have a lot of shards. We potentially have a lot of replicas, and we also have Zookeeper out there, which, at least in the current version of ClickHouse, is necessary to keep the replicas in sync. So what you end up having to do is, if you were going to just use a file to, like what we showed a few minutes ago, you would actually have to have an extraordinary number of resources. Moreover, you'd have to be constantly changing them every time your usage changed and you decided to add more resources, for example, to scale the service. So that would be really painful. You've seen that file. It's not a pretty sight. Fortunately, there's a solution, and this is something that it's called an operator. And this is a new feature, relatively new feature of Kubernetes. It really became, it really was developed, sort of first appeared a few years ago. And basically what it does is an operator allows you to define new types of resources in Kubernetes. And so we have something called the ClickHouse Operator that we developed. And what it does is it will consume a resource definition for ClickHouse that's just a single file, relatively simple. And when it comes in, Kubernetes will send it to the ClickHouse operator, which will look at it and then go through this process again of adjusting reality, of defining the underlying Kubernetes resources that are necessary to create the cluster. And that gets what we call a best practice deployment, where basically it'll set up ClickHouse. It will do all the configuration files, which are relatively complex. It can help you, ensure that you get the right amount of storage, so on and so forth. It provides monitoring. It provides a bunch of stuff that's necessary to really run ClickHouse, particularly in production on Kubernetes. And this all happens from a single file. So in order to use this, the first thing that we need to do is we need to install the operator itself. This shows the commands. It's really simple. We'll just apply them in a second. And by default, we put it in kube system along with all the rest of along with all the other system resources for Kubernetes itself. Second thing we need to do is, because we depend on Zookeeper, we'll actually need to install Zookeeper itself. Now, we don't have to do that because I just did it a minute ago, but this shows you the commands to install a development version of Zookeeper. And by the way, if you're thinking about repeating this at home, and I hope you will, this is a dev test environment that we're creating here. It uses one Zookeeper node. In a real production environment, you would always have 3 Zookeepers. That's the recommended number. You might have 5, but you would certainly not have 1, because if it goes down, ClickHouse replication will stop working. So rather than diving into the details of the specification that we use to define ClickHouse, it's just simpler to show you how it works. So let's go in and actually bring up a data warehouse. So we'll put away the slides and we'll go ahead. And the first thing that I'd like to do is I'm just going to run those commands to install the operator, just in case it's not installed. So what I did was I just pulled down the definition of the operator. So we'll show the commands here. So it's just a wget. I'm running on Ubuntu here, so all my nice Linux commands work. So I do the wget, I pull the file, and then what I'm going to do is run kubectl apply -f, and it's simply going to apply this file. If you go look at the details, this has a bunch of information defining the ClickHouse operator, what sort of entity it manages, a bunch of things that allow Kubernetes to understand how to fit it into the API. And then once it's running, within a few seconds, it'll basically pull that container, deploy it. And in fact, we can see that within 2 seconds, this was up and running. It might have been there already, in which case Kubernetes is just checking to make sure it's in the state that we asked for. So there it is. That's all there is to installing an operator. It's, in this particular case, a total of 2 commands, actually. So we don't need to do Zookeeper because it's already out there, but what we'd like to do is go ahead and install our cluster. And let's first have, before we do that, let's just do an ls here, cluster.yaml. So here's our YAML file. And you saw that complex cluster for Zookeeper, which was already less complex than ClickHouse. Let's just look at the configuration here. It's relatively simple. So we define this thing called ClickHouse installation. We'll talk more about this. We have a little bit of information about what the cluster should look like, where to find Zookeeper, because we're going to connect to it. And we're going to also have some templates which define what kind of pods do we want to start, and for example, their version, as well as storage. We'll look at the details of that in a few minutes back in the slides, but this is relatively simple and very little, very little stuff to fill out to get a working cluster. So let's go ahead and apply that. I'm going to run a script again just to make sure that I get everything. Oops, not that one. We're going to go ahead and install the ClickHouse cluster. Relatively simple. It's just going to run kubectl apply -f, and what we can see is I have some what this shows here is you can see the pods starting up from the stateful set in the default namespace. That's where it's running. So we've already got one of the ClickHouses up and running. Second one is now running but not fully ready. So we should see that. Moreover, if we look down below, we see that we've got storage. I'm just checking to see the storage requests, and we can see that those requests have been made, and we'll check in a little bit, but they have will have storage attached to them as well. At this point, we've got a cluster up and running, and we're ready to go log in and talk to it. But what I'd first like to do is show you a few of the details about how we got there. So let's go ahead and pull the slides back up. Just one second. All right, there we go. All right, so let's just look in more detail about what's in that resource file. So if you're going to run Kubernetes yourself, you're going to need to fill this out. We have examples that you can use, but this will give you kind of the highlights of this file. So first of all, as I mentioned, the resource type, that's ClickHouse installation. Actually, this arrow is pointing at the name of it. It'll kind of miss there, but this says that when Kubernetes sees this, it knows that this needs to be handed over to the ClickHouse operator to go figure out what to do with it. And it's got a name so that it's unique, distinguishes it from other clusters you may be running. And then within the configuration, we can define a specific cluster. So I call this one demo. And I asked for 2 shards with 1 replica each. And then you see I have a couple of references to these things called templates. One to tell me how to find the ClickHouse executable, and the second one to get some persistent storage. We'll look at that in just a second. And then finally, I have a section to tell me how to find Zookeeper, because ClickHouse will need to know its name so that it can go ahead and put that in the configuration files. So then under the templates, we see the further definitions of, first of all, the pod. So this is saying, hey, I want to run ClickHouse. I want to run version 21.6. This is the Docker server that comes off the community builds, which are created by Yandex. And so it comes off their Docker Hub repo. And then we have what I call volume claim templates. And as you can see down at the bottom, this is going to ask for, this is similar to we use the same syntax here as you do in a normal Kubernetes volume claim. Give it a name, see how much we have. The access mode read write once, that just says, hey, this is not going to be shared this is not a distributed file system shared by a bunch of pods. It's just used by 1 pod. And then finally, a very useful property here called reclaim, or reclaim policy. And this just says, hey, if I delete the cluster, don't delete the underlying storage, because maybe I did it by accident and I'd really like to get it back. So this is useful to help protect your storage from fat fingers. So these are the definitions, and that was sufficient. These few lines of code was sufficient to get me a fully configured ClickHouse server with a couple of shards in it up and running. So when we actually go to, when you actually create a ClickHouse cluster, what I recommend doing is just some basic operations so that you can, make sure it's in good state, and check into it, and then actually make it available externally. So first things first, I always go and check the persistent volumes, make sure it really has storage. We can repeat this when we get back out to the demo environment. Second thing is you can get into it quite easily. We'll show this shortly. You can just go ahead and use the kubectl exec command. That's a way of getting in and directly talking to to one of the ClickHouse instances. And then finally, if you're using Minikube, what we commonly do is we do what's called port forwarding, where we just expose that service for ClickHouse. It's called ClickHouse Kubernetes. We just expose it on port 9000, and this allows clients outside of Kubernetes to connect to it and use it. So these are 3 things that you'll do when you get set up. And at that point, you're ready to start playing around with ClickHouse and developing applications. So here's what we've created. We saw this in the kubectl commands that were getting the resources and showing what was going on. We have Zookeeper, which we set up at the beginning in its own ZK namespace. In the default namespace, we've got ClickHouse running version 21.6. And we don't have any replicas. We've only got a couple of shards. So here's a question. How can we make it better? Well, I'm going to show you 3 ways that you can improve this. And the first is we could add more replicas. So, and the second is we could change the version. And the third is we could actually add a user, which wasn't easy to put in this picture. So I didn't do it, but I will show you how to do it in the configuration file. So let's walk through the different ways that we can do this. So first of all, increasing the number of replicas. All you have to do is go into the specification file and just change the count of shards and the count of replicas. That's it. So they will pop up and start to run, or as soon as it reads this, the operator will go ahead and create additional nodes so that the shard and replica count is fulfilled. If you decrease it, by the way, it will, for example, remove replicas. So you can also scale down as well as scale up. Another thing we can do, as I mentioned, is add a user. This is an example of adding a user which is able to do what is called RBAC management, role-based access control, or SQL role management. So I call it root. It's got a SHA-256 password. And so, if you're familiar with defining users in XML, this basically will fill out an XML file so that we can get into the server and actually do additional SQL operations to create the rest of the accounts. So that's how we define a user. Final thing is, how do we change the ClickHouse version? Very simple. All we have to do is go ahead and change the pod version, and voila, it will just go ahead and sort of when it sees this file, it'll pull the appropriate pod. So these are simple ways that you can improve your ClickHouse cluster using the Kubernetes, using the specification file. And it's finally worth talking about, like, what actually happens when that file is processed. So when we have a file which has any of these changes, what will happen is that you load the file using kubectl apply -f, as we showed before. The operator will get the file, it'll be forwarded by Kubernetes. It will go out and look at the resources and then come up with a plan for doing the upgrade. So let's say we had 4 pods already. Say we were at 2 shards, 2 replicas, and we asked to change the version. What the ClickHouse operator will do is it will go around and it will restart each of the pods in turn to bring it up with, and then when the pod comes back up again, it will be a container using the new version. Or we could have increased the memory or the CPU or other resources available to the pod. The key thing here is the operator does this sequentially, and the idea is to make changes to the cluster which do not cause your applications to go down, because we do things one at a time, and at any given time only one replica is down. So that's the process. Let's go ahead and illustrate this as a demo. So let me go in and we'll come back, and let's just actually show a few of the commands I mentioned. So for example, checking for storage, we can go ahead and run the kubectl get PV command that shows our persistent volumes across the entire system. And here we see persistent volume, and it's bound to, we can see that's actually the name of the request, but we can easily track which pods they belong to. So this is good, and we see that they've got 10 gigs allocated. So we feel good because we know that if we're putting data into it, it's not going to ephemeral storage and it won't disappear when the pod goes away. So that's good. Getting into the pod, let's go ahead and we can use kubectl exec, and it's a little bit let's actually get our pod name here. So we have to give our pod name. Let's go copy that in. So we're actually just going to use bash, and we'll go straight in. We're now inside the pod, and we can have a look around. We can see that we're actually in the ClickHouse server directory. If you're familiar with ClickHouse, you can go and make sure that all the configuration files are done correctly. Take it from me, they generally are. One other side effect of this is if you're just learning Kubernetes, or more to the point, if you're just learning ClickHouse, this is a really great way to see how to configure a ClickHouse server properly. What you can do is bring it up on Kubernetes. The files are all generated from you. If you then want to go install on VMs, you can go use those as examples that you can copy and then set up ClickHouse in other locations. So, and finally, we can get into the ClickHouse server itself with ClickHouse client. We come up and we're running. We can see it's version 21.6. Let's just confirm that, and here it is. It's 21.6.7.57. That's the actual build. So there we go. And then the final thing is port forwarding. I won't do that, but well, actually I can. Why not? Oops, let's get out. I have the port forwarding command in a script. There it is. So this is just an example of how to port forward. I'm just going to run that. And at this point, I can now connect from the command line. Let's see, this should work. I've remapped the port a little bit to avoid colliding with another ClickHouse server, but okay, in we go. So I just connected in from an external client. So at this point, you're set up and ready to do development. Let's do the last part of the demo, which is just to demonstrate how the upgrade works. So we'll go ahead and quit out of this. And what I'd like to do is do a quick diff of the cluster YAML file that we installed and the new one that we're going to install to add. In this case, we're just going to add replicas. So let's diff those two files so you can see the change. It's really simple. We just change the replica count. And now what we're going to do is go apply the new file. So we'll just run the command for that. There it is. It's as simple as kubectl apply -f, name of the new file. And then what we'll see is if we go over and look on our display on the upper left, we're going to start to see new entities emerging. So for example, we can see, and the print may be a bit small, but you can see there's a new pod coming up. There's also a new persistence volume claim, which is going to allocate storage. As soon as that pod is up and running, we expect to see another replica coming up. There it is, container creating, and we see a corresponding persistent volume request. So that's an example of how to do the upgrades. It's very, very simple. This is a very powerful way of organizing these things that then works very well, particularly as you get large production systems. And in fact, we have customers that run these. We ourselves run our entire cloud service on it, and then many of our customers run on Kubernetes. We have they're running on clusters in some cases that contain like 50 to 100 nodes on them. So these are major systems. So with that, we're done with the demo. Let's go back and conclude the talk. So here's how to get more information. This will basically get you started. So you can go and look at the code for the ClickHouse Kubernetes operator. This is, just Google that, or when you get these slides, the link will take you to the GitHub project. We also have Altinity documentation at docs.altinity.com. There is documentation for how to install the Kubernetes operator and bring up clusters in Kubernetes. There's community docs, which for ClickHouse itself. So they are quite extensive and are basically covered. They're basically the reference document for ClickHouse and the SQL dialect that it uses. And then finally, there's the Altinity blog. We write constantly about ClickHouse related topics, including how to run it on Kubernetes, but you'll find all kinds of things there, everything from BI tools to how to manage storage to tricks with new SQL features. So with that, we are complete. I'll just leave you with a few links. You can get to ClickHouse on GitHub, that's shown here. Our Altinity website is at altinity.com. And if you want to find out about the cloud, it's pretty easy to, if you don't want to bother with the ClickHouse, running ClickHouse itself in Kubernetes, you can let us do it. We're happy to do that. And finally, since we're on the topic of things that you can find on the website, we have a bunch of job descriptions. We're hiring and actively looking for people who know, experts in Kubernetes and cloud technology, ClickHouse itself, and other topics, so or other areas. So thank you very much. I hope this talk has been useful. I'll open it up for questions, and if there are any, I'll hang around and answer them. Otherwise, we will conclude the webinar. So with that, let me open it up for questions. Feel free to post them in the question box if you have them. Let me just have a quick check to see if we've got any that have queued up. Don't see any open questions right now. For those of you watching this later in the recorded version, we're doing this in July, right in the middle of vacation, so it's a bit of a quiet time for webinars. Okay, so I don't see any questions coming up. Well, thank you all very much for attending. I hope this has been useful. Please do contact us at Altinity if you'd like to look into this further, and have a great time running ClickHouse on Kubernetes. Thank you very much and have a great day.